Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer, author, and software architect.
And I'm Beej, the journeyman developer sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
Understanding memory can be a tricky thing, especially the deeper into a computer system you get. To help understand it, a hierarchy of memory was conceptualized. This triangular shape helps to visualize the different levels of physical memory storage in a system. In this episode, we explore the memory hierarchy from the top down. We'll look at CPU registers, caches, RAM, storage, both internal and external, and even take a brief break to talk about virtual memory. But before we get started, Will, what's been reminding you lately? I don't know. That was bad. Yeah.
Kind of hard to roll that one, huh?
Uh-huh.
I have been working on writing lambdas using TypeScript, and that also includes some work with the Amazon CDK. So basically, you have components for specifying pieces of infrastructure. So you're doing your configuration as code. So it's nice, reusable. It's pretty slick. I do not overly love the user story for C# and .NET on AWS, especially when you get into like the lambdas and those kind of things. Like they're kind of nasty to work with in spots, or they feel like they're a lot more trouble than they should be.
Yeah.
But it is clean with TypeScript. So that's what I've been doing today. It's been interesting. How about you?
Well, I had a photo shoot this past weekend. My friend from Germany, she was the model. I think I showed you last night one of the photos that I really liked. I'm actually contemplating. I got to talk to her about it, make sure she's cool with it. But I really like this photo, and I've always wanted to get one of my photos on a Jones soda can or bottle, I guess. So I am seriously considering sending that in to Jones to see if they'll put it on one of their bottles. It's really cool. We sort of a punk rock themed photo shoot. We used my guitars as props in a background. So I'm in the process of editing the photos to show at the art show. So that's going to be cool, which that will happen before this episode airs. So in other news, I need a new printer. I've been taking some of my poems and putting them onto Canvas via Mod Podge. Actually, I was doing that before we started. Will was making fun of me because I like to wear this overalls that I have for painting and stuff like that. And so he was, picking on me about my
That's
my
where he
outfit.
parked his tractor.
Yeah, he did. But yeah, because I even have like the white T-shirt on too. Like Farmer Beej over here. So, but yeah. I have to go to a print store to print off the poems that I cut out, and then I Mod Podge onto Canvas. But yeah, my printer it's just like got lines that are missing, just like really thin. Like sometimes they're a little thicker, but just like white lines through the text. If you're printing off something to read or study, not that big a deal. You can kind of figure out what it's saying, but printing off something to put as a piece of artwork, not so much. So been trying to decide if I want to like spend a little money, get like a laser printer, something really nice, or stick with the cheap printers like I have been in the past.
Get a brother like I've got. Dude, I tell you what, if we ever have nuclear Armageddon, cockroaches will be printing out stuff on brother printers.
Oh, really?
Afterward. Yeah, because they'll both still be alive.
That's cool. Well, yours though is it's only black and white.
Right.
Yeah.
But it's never been a single problem other than the occasional jam.
Yeah. I might do that and do like something cheaper for color. I don't need that much color printing. I was looking at Canon photo printers as I delve more into the world of photography. I think that's going to be the way I go. So I can print off my own stuff. That would be really cool. I was talking to one of my friends at church. Our worship director, and I was telling her, I'm like, I kind of want to get one of these, but they're kind of expensive, so it'll be a little bit before I get one. Like, like
Yeah.
$1,500, something like that, 2,000. There's other things that I want and need before that, like a new camera, more important, things like that. But eventually, that is on the list of things to get, which would be really cool to have that, especially if it's a business expense and I get to write it off because I'm using it for a photography business or something like that. Or if we do something that requires, printing, I could use it for podcast printing. There we go. But no, I'd probably use it for the anyway. That's kind of what I got going on. Saving money is hard, especially when you've lost your memory.
Lucas Casades is a fee-only certified financial planner. He owns and runs Level Up Financial Planning virtually out of Fort Collins, Colorado.
And just like us here at Complete Developer Podcast, Lucas focuses on helping you not only establish a real plan, but take action so that you can live your best life.
Investing in financial planning services really comes down to whether or not you can improve your finances. And with the help of Level Up, the compounding impact of making better financial decisions will easily pay for itself.
Level Up has a unique pricing model that will help you no matter where you are in your financial journey. So whether you're a junior starting out or a grizzled senior ready to retire, Lucas can help you.
Like how you pointedly looked at me when you said that. Lucas is also a fiduciary for his clients, which means he's not here to sell you a product, but to help guide you into a better financial situation.
You guys can catch his podcast, Techie Personal Finance Bootcamp, where he covers financial topics you probably face and interviews other IT professionals who share how they navigated their careers. You can also learn a lot more at levelupfinancialplanning.com.
Computers store data at different levels throughout the system. The memory hierarchy is a pyramid or triangular structure that helps to visualize the relation between size and speed of different types of physical memory. The top of the hierarchy being the smallest and fastest, basically CPU registers, and the bottom being the largest and slowest, that would be your external storage devices.
Yeah. When a processor needs a particular piece of data, it will start at the top of the hierarchy and work its way down level by level until it finds the data that it needs. The top 3 tiers of the hierarchy, the registers, caches, and main memory, are called volatile memory because they rely on power to retain data. When the power source is removed or turned off, they lose the data that they're storing. The bottom levels are considered permanent storage because they will retain the data with or without power.
In this episode, we will explore the different types of physical storage on a computer from the smallest CPU registers to the gigantic external hard drives. This is an overview of the different levels, as each one could really be its own episode, going into the specifics and details about it. In the aftercast, we're going to talk about your own memory and some things you can do to improve it.
Yeah, I really didn't have much for what to do on the aftercast that related directly to this without going into the weeds. So I was like, hey, memory, let's play with words here. But guys, seriously, you should check it out.
Speaking of playing with words, we should start with CPU registers. You like what I did there?
I love it. That was great, dude. That was great.
So CPU registers are the fastest and smallest of all memory. These are static RAM that exists on the processor that allow pretty much instant access. They usually hold a single word, 64 or 128 bits.
Depending on your processor,
Yeah.
like most modern processors are going to be 64 or 128.
Because like I know back in the day, it was I dealt more with like 16-bit and 32-bit.
You could have some older systems that are 16 or 32-bit.
Yeah, or low power systems.
Yeah, that's what I was going to say. Or some like device things or other things like that that are going to be less. But your average computer is going to be 64 or 128 bit.
Yeah. And just to clarify, a word is the natural unit of data used by a particular processor design. So it's not quite like a byte in that it kind of shifts in size based off of what you're dealing with.
Mm-hmm. Yeah, that's why it's called a word, because a word, can be shorter or longer.
Right. And it excels at access.
Little quote from Braveheart: "Some words are longer than others."
Right. It's a word.
Physical space is highly limited on the processor. So this reduces the number of registers as each one takes up a certain amount of space on the processor. Only the most important information is contained in these registers.
Yeah. And it's usually the stuff that you're working on at that very instant. That's what
Yes.
we mean by important. Because things will be shifted into the registers and operations happen on them, and then stuff comes back out into memory.
Mm-hmm.
And that happens at a low level in your code.
Yeah, you're
Now,
not likely to be. I mean, I have written stuff that deals with registers, but that was in class. Very rare.
I've had a few occasions to poke around in there. I typically will try to stay up above that level of hardware.
Yeah.
Unless it's things have to be pretty dire, because that's a different headspace than normal programming. You're kind of getting into electronic engineering, not software development.
Yeah. I really enjoyed. I had one class where basically throughout the class we kind of built our own operating system, like virtually. And this, did I let you borrow that book? I know you asked for it.
No, you
But,
didn't.
okay, I'll have to bring it to you next time we get together. But yeah, it was a lot of fun to do that, to like go through that process over the course of a semester. So if you guys get the chance, I'll have to find the book and put it in the show notes so you guys can look that up. But it is a lot of fun. Book's probably expensive because it's a school book, but
Yeah. So different manufacturers put different registers on their processors, different numbers of registers, that kind of thing. Systems designed for complex instruction sets have fewer registers because they're designed for accessing main memory, whereas reduced instruction sets have more registers.
So the book, I just found it. I looked over and saw it on my bookshelf. It's called "The Elements of Computing Systems: Building a Modern Computer from First Principles, NAND to Tetris Companion." It's kind of fun. You guys, like I said, definitely worth it. So check that out. The program counter is a register common to all processors. It keeps track of where the next instruction that is being run is located. So it points to the next instruction to pull it into the register. A few other common registers include a register for decision making, an accumulator for math operations, things like that.
Yeah. And that the program counter is especially interesting because that's kind of one of the implementation pieces of a Turing machine.
Yeah.
Right there on your processor. So stepping up from the register level, or stepping out physically,
Up and out. Up
well,
and out.
it's like there's the pyramid that's like the speed and the size. Yeah, it's a higher
Yeah.
speed and it's smaller size. But
Yeah.
I always think of it as going down into the processor because I don't know. And I know that that's backward from
Going down the pyramid, out of the processor,
Yeah. So like yeah. So basically don't take directions from me on this one.
I wouldn't
You're
take
gonna go the wrong
directions from
direction.
him, most times
Yeah.
anyway. Use your GPS instead, trust me.
Yeah. So the next level is the cache. And this is the next fastest after the registers, but it's got more room in it. Cache can be found on the processor or on another chip closer to the processor than main memory. It's larger than a register, but smaller than your RAM.
Cache contains chunks of data from the main memory, the RAM, that are used frequently. The more often a piece of data is called from main memory, the higher its likelihood of being copied into the cache.
Yeah, from the view of a program or app, the cache doesn't really exist. At least typically, you're not going to actually interact with it directly. Programs request information from main memory, and if it's stored in the cache because it is used on a regular basis, then it's available more quickly. Just like a normal cache in a web app, it's a cross-cutting concern.
Yeah.
Although you can directly manipulate it from some languages. They're low level enough, but
And that you can, and again, I've done that in school. It's not something you're going to do very often unless you're like writing operating systems.
Yeah. Or like video processing or
Yeah.
some of those kind of things that are real intensive. You might actually get in there, but it's hard to mess with that in a way that actually helps you.
Yeah. Cache is divided into levels based on size, location, and usage. Single core processors typically have up to 2 levels of cache, whereas multi core processors will have 3 to 4 levels, basically 2 per core, and then 1 or 2 shared levels. And so we're going to kind of go through the different levels. I've numbered them kind of weirdly based on how they are in here. But this information is directly from Wikipedia. Will and I looked it up also on Intel, and it's a little like the speeds and stuff are a little bit different there. But we're going to go with what we pulled from Wikipedia because that's what I copy and pasted.
Well, Wikipedia is brilliant, right? Get nerds to argue about minutia and make money off of it.
True. That's true. That's true. So the first level that we're going to talk about is, of course, we zero index here, so it's level 0, and this does not count as your first 2 levels, I guess, because there's level 1, 2. There's level 0, level 1, level 1, level 2, level 3, and level 4. So level 0 is L0 micro operations cache. This is the smallest at about 6,000 bytes, 6 kilobytes, and also the fastest.
Yeah. And my understanding is that this is used to reduce power utilization in a lot of chips. I did see that there was a thing on side channel attacks on this as well. So there's other fun to be had here.
Of course,
Look
there is.
how close in you can get before you get
Yeah.
the scourge of our time. So the next level above that is the instruction cache. And this is 128 kilobytes in size.
And then also at level 1 is the data cache. It's separate from the instruction cache, but they're both considered level 1 caches. And that is also 128 kilobytes. With these have an access speed around 700 gigabytes per second. I forget what it was. It was faster on the Intel site, but I think that was at like their optimized chip speed too. So
Yeah. And who knows, with some of these other mitigations they've had to do, I don't know, are these numbers before or after that? Or do they even matter?
Yeah.
So the next level is the L2 cache. That's your instruction and data shared cache. That's 1 megabyte in size. The best access speed there is around 200 gigabytes per second. And I know people that have had to manipulate the L2 cache for some of their work for video processing.
Yeah. Yeah, I can believe that. That makes sense. So the next 2 are in multi-core processors where they are shared between cores. Levels 1 and 2 are per core, and then 3 and 4 are shared. So these are both called shared cache. Level 3 is roughly around 6 megabytes in size, and it typically has the best access speed around 100 gigabytes per second.
Yeah, then your level 4 cache will typically be around 128 megs in size, and the best access speed there is around 40 gigs per second. So you can kind of see that, like, as you get closer into the CPU, it's smaller and faster. And you can think of this as a function of geometry, right? Like the amount of area that's available close to the processor is smaller than the area available further away from it.
Yeah. So moving on out, we'll just call it out. How's that? That works for me and you. Moving on out from the processor, from the cache, we have our main memory or random access memory, RAM, as we like to call it. Significantly slower than the processor's memory, both registers and cache, and generally stored a bit of a distance away from the actual processor. And by a bit of a distance, we mean a bit of a distance for electrons. Like, there's not a lot of physical distance for us big old humans. The main memory is much larger than memory stored on the processor. It's got a lot more space to have physical space to build it out. And each time the processor has to access main memory, it slows the running process down because it does take longer to access it.
And you can do some optimizations in some cases to get stuff loaded into cache before you need it, which obviously that's going to be at the compiler level more than anything that you or I are going to touch. At the time of this recording, it comes in the gigabyte range, and that's in terms of space. Windows cannot really run on less than 4. Windows can't walk on less than 4. Like if you turn it on with 4 gigs, yep, you have Windows. Enjoy Notepad because you're not going to be doing much else. You can either run Windows or one Electron app for one typical Angular website. Sorry.
Yeah, pretty much. We were talking about memory. I had to throw a Windows joke in here somewhere. So your main memory or your RAM contains most of the data and instructions that are necessary for the programs that are currently running. With the others, the register and the cache, it usually has like the current running process. These are, because it's so much bigger, it contains the data and instructions for multiple programs here, not just processes. When there is excess RAM, some operating systems will cache data of common programs to make the loading of them faster.
And there are 2 types of RAM. There's DRAM, which is dynamic RAM, and it's the most common used in a computer's main memory. It's made up of a circuit of cells, each containing a transistor and a capacitor. SRAM, or static RAM, is less common and consists of 4 to 6 transistors.
So, as we said in the intro for the episode, this is the end of the volatile memory going out from the processor. So, power is still required to maintain state in main memory. If the power is lost, then the information stored in the RAM is lost. So, DRAM requires an electrical charge to be refreshed every few milliseconds. So, because of its use of the capacitors, it can store a little bit of a charge for a time. However, SRAM needs a constant electrical current. This makes it a bit faster, but a lot more expensive than DRAM.
Well, and probably less stable too in residential power situations, I would imagine. So, stepping on out, secondary memory. The way that main memory is built, it's not able to retain data when there is no power to the system. Secondary memory is where data is stored long-term for retrieval between power downs. It consists of solid-state drives or hard disk drives.
Most of us are pretty familiar with this, but we're still going to kind of go over a light review. Solid-state drives or SSDs are faster than the hard disk drives, HDD. I'm just going to call them hard disk drives. It feels weird saying HDD.
Right.
Because they don't have to wait for a disk to spin up and find the location on the disk once it's spinning. However, this does make them more expensive. Therefore, it may be cheaper if you need a large amount of storage in the terabyte range to purchase a hard disk drive. That is getting cheaper though.
Yeah, I was going to say I've got a 1 terabyte SSD in this box here, and then 2 4 terabyte, regular, spinning platter hard drives, spinning rust. Yeah. Well, the thing is every time I hear it spin up, I think, could I replace that with an SSD? With replace both of those with SSDs? I've seriously considered it. It's like it could be faster.
Mm-hmm.
Of course, I don't know that I'm actually, I kind of suspect I'm not actually limited there. It's more like, hey, I just don't use the computer enough to actually really need that, but who knows?
I mean, I get that. But the thing is, SSDs also wear out faster than hard disk drives, which you would think because of the spinning disk, that wouldn't be the case. But it is. It's a very interesting thing. It has to do with the way the data is written to them. It's on the solid state drives, it's written in pages, but removed in blocks. So, for example, when a block of data is changed, like, altering something in a document, then the old page is marked as invalid and a new page is created for that data. And so it's not a big deal when there's plenty of space, like fresh space on the solid state drive when it's earlier in its lifetime. However, when there are no more new pages, the invalid ones are then overwritten. Basically, this whole process causes extra writes on the disk, which leads to wear as each write wears down the cells of the SSD.
Right. I mean, the big deal with the spinning platter is what happens if it gets smacked while it's running.
Mm-hmm.
Then you have like a head crash or something. But if it's not subject to vibrations or shocks, it's going to be far more durable just because it's like a record player versus, the tape deck in your old car or your current car.
Yeah, the tape deck in my current car doesn't work, which is sad because tapes are super cheap.
Yeah. But
I mean,
because
CDs aren't that much expensive. More expensive? Anyway.
But because the way that you interact with it, it's more likely to get jammed up, essentially, and the environment in which it lives.
Oh yeah, I remember back in the late 90s, even into the early 2000s. No, I had a CD player in my car when I was in college. So yeah, the late 90s. Yeah, you always kept a pencil in the car so you could wind it up, and anyone younger than 30 probably has no idea what I'm talking about.
Right.
Might. But yeah. No, I do remember keeping a pencil in the car just for that very reason. Secondary memory doesn't require power to retain data. That's one of the benefits of it. It's also more dense memory as it has a much higher storage capacity with less cost than any of the previous forms of memory.
Data stored in secondary memory is loaded into main memory before it can actually be used for a running program. And this accounts for most of the load time when you start an application or when you retrieve data from disk.
Yeah. So now we're going to take a brief break from our journey outward from the processor and talk about virtual memory. Since RAM is limited, yet required for running programs, if you don't have enough to run all the active programs on a system, like, when your operating system is Windows and, it requires 6 to 8 gigabytes of RAM just to run the operating system, it will use a feature called virtual memory. What it does is it compensates for the shortage of RAM by transferring some of the less frequently used data to disk storage or secondary storage.
Right. You can almost kind of think of it as like credit for your.
Yeah.
It's like you have your bank account and this is credit. You're going to have to, there's a cost to getting it, but it's there so that should you need it.
It's like overdraft protection.
Yeah. And it does big time slow stuff down.
Oh yeah.
Yeah. Virtual memory blends your main and secondary memory. So when RAM starts running low, the virtual memory will transfer data from the main memory to what's called a paging file on your secondary memory, usually your hard drive. If virtual memory is low, then either the paging file size needs to be increased or more RAM needs to be added so that less virtual memory is used. And I will also add another thing too, is that file can get fragmented.
Yeah.
And so you have like an addressing problem in some cases, or you have stuff that is not freed quickly enough.
Another thing you can do if you are low on virtual memory is to switch off of Windows to a Linux distro.
Yeah. Because then none of your programs will load and you don't have to worry about using all your memory.
Yeah. No, but that was the issue with the crap top was Windows. It was fine with Windows 7, but Windows 8, like it only had 4 gigs of RAM, and Windows, the operating system, used all 4 of them and some of virtual memory.
I feel like there was an issue too with Windows 8 where it allocated virtual memory on disk in a way that caused it to be extremely fragmented. And so what ends up happening is at some point it basically kind of defrags that memory.
Yeah.
Or it maybe it's when it does that same thing to the actual running memory, it like writes it down,
Yeah.
and then reloads it in a smaller memory space. But like that operation really hurts.
Oh yeah, we could do like a whole episode on just virtual memory and defragging and all of that.
Yeah. I mean, anytime you have a dynamic
Yeah.
address space.
No. The transfer of data from RAM to the paging file on secondary memory is called swapping. Now, again, this is a temporary solution that's basically designed to allow the RAM and secondary memory to work together when you don't have enough space on the RAM. And as soon as that space clears up, it should like swap back, pull that back into your main memory.
Right. But, a badly behaved app can totally screw you over there. Virtual memory use slows down the programs being run because it costs time to write to the secondary memory and then retrieve the data when you need it. And that's especially bad if you have a slow disk. So like you have one of those, was it 400 or 4200 RPM, laptop drives, which is what the crap top had.
Yeah.
Like anything that you get off that disk is not going to be fast. Running system memory off of there, definitely not cool.
Yeah, the other problem with the crap top is we were just going to put more RAM in there to fix the problem, but it was a cheaply built laptop that we weren't able to upgrade the RAM. I remember that
and
being
we
an
looked at
issue.
putting an SSD in there as well. And that was a problem for a different reason. And I can't remember what the deal was there. I think the SSD was worth more than the box for one thing.
Yeah. Though I will say when I put what do you remember what distro I did? Was it Ubuntu on there? Yeah, I think it was.
It was Ubuntu. Yeah.
Yeah, when I put Ubuntu on there, it worked fine.
Oh yeah,
didn't have a problem. So yeah, it was all Windows,
and it might have been Lubuntu.
No, it wasn't. That's what I put on my mom's. No, I put the lightweight on my mom's, who had 512 megabytes of RAM.
Yeah. No comment.
Hey, she was still running XP on it, so yeah,
that's low for XP.
Yeah, it was. Yeah, that's all I'm gonna say. So, the final thing we're going to talk about, going back to our journey away from the processor, is external storage. So, this refers to any form of data storage external to the system, and it can include external hard drives, flash drives, CD, DVD drives, floppy disks, magnetic tape. I mean, yeah, we could go on and on. Was it zip drives?
Jazz drives, zip drives. The Jazz drive was like a gig.
Yeah.
Zips were 120 megs. I think I still have one floating around here somewhere.
Oh, man.
But yeah, external storage devices can be removable from the system, because the data is expected to be moved around from machine to machine. These are typically slower. There's the old commentary about, never underestimate the bandwidth of a minivan full of backup tapes.
Yeah.
Like you move your data center in that van.
Mm-hmm.
That's the kind of external storage we're talking about potentially.
Yeah. And it can make transferring files or taking files to the print shop easier. And like Will said, it is definitely slower than secondary memory. However, USB 3.2 and Thunderbolt have gotten speeds pretty similar to some slower secondary memory. So some hard disk drives.
Right. Of course, now your hard disk drives are going to start speeding up too.
Yeah, that's true. But no, it's getting faster and it's getting better with the better ports, I guess.
Yeah. And you can kind of look at online storage as just being a unique form of external storage, because really you're storing it on the internal storage somewhere else.
Yeah.
Like it's somebody else's machine. Like you throw something in an S3 bucket, like that thing exists somewhere in a server rack, and Lord only knows where. But
yeah.
And this could also be storage solutions like a network attached storage. I mean, that's what I've got here. for all of my stuff, back stuff up, syncs files. I got a crap ton of Docker containers running on it. That's essentially another computer.
Yeah.
Well, it is another computer. It's not essentially another computer. There's just no monitor plugged into it or anything like that.
It's a
but yeah. So this covers a lot of ground, really, when you start getting external.
I think the next time I build something headless, I'm going to name it Horseman. Well, because like the Raspberry Pi cluster I built was headless, and get it, Headless Horseman. Bad joke. It's really bad. It was like a dad joke, and I'm not even a dad. So
that was an insufficient dad joke.
Yeah.
You should swap it out for another one.
Oh my goodness!
Try not to have it in your memory. See what I did there?
Yeah. I saw what you did there. Guys, this is just a very high-level overview of the different types of physical memory involved in the computers we use and the programs we write as developers. Each one of these levels can be expanded upon. If you're interested, dive deeper into understanding how each works and interact with one another. Use this sort of as a starting point or even a refresher to dive deeper into understanding how the systems we use store and transfer data. That's pretty much it. Before we close everything out, Will, what do you have for us this week for tricks of the trade?
Well, you'll notice when you look at the different memory types and sizes and those kind of things that multiple levels of optimization are offered. And there's a reason for that. There is a cost for any optimization that you make. Sometimes you can take a piece of code and you can just overtune it, and that's great, but it takes more development time to do that. And if you're not getting your bang for the buck, that may not be a real good idea. You'll notice with this kind of mature architecture, you'll tend to kind of see these sort of things in programs as well. There'll be certain parts that are just really, really optimized because they found out that they had to do that, and that it improved overall system speed. Whereas there's other parts that are basically your app's equivalent of external storage. Like a lot of your batch processes that run at night tend to be those kind of things, right? Like they're optimized enough where they can run in a reasonable amount of time, but you're not expecting them to come back immediately. It's always useful when you're starting to optimize things to actually figure out, okay, what pieces do I need to optimize and what is a good stopping point for that optimization? Because there is a break-even point there. They could potentially do something to cram more registers into a CPU, but that may not actually make it faster because of other forces out there. And we have to kind of take this same approach when we write code. There are optimizations that you should not do. And that's pretty much all I got.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
For references, show notes, and extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. Help us make the show possible by supporting us on Patreon at patreon.com/CompleteDeveloperPodcast. You'll get extras, including a weekly aftercast where we discuss the topic of the week and bonus material with some of our patrons.
You can also follow us on Twitter at CompleteDevPod, like our page on Facebook, and follow us on Instagram to keep up with news about the show. Join the conversation anytime via Slack by signing up at slack.CompleteDeveloperNetwork.com. Thanks for listening. See you next time.